This is a whole new topic. We are going to talk about electric current. We have been looking at electrostatics, and that's saying we've got some kind of a charge sitting here and there's a lot of things going on around it, and because of those things going on, we get forces and we get fields and we get potentials and movement and all kinds of things. But what happens once the charge actually does start moving? If we have some location in space, we can measure how much charge passes through here. And if we can do a time rate of that, so if we can talk about how much charge passes through per unit time, we call this an electrical current. Electric current gets a letter of I, for the most obvious of reasons, of course. It gets a letter of I. It's not actually an obvious reason. We use a c to be the speed of light, and we need some other letter. The I actually comes from a French term about intensity of current, and for whatever reason, that particular one stuck. So we end up with I, not a big deal, and I is going to have units of coulombs per second. But we use current often enough to where we define a new unit. 1 coulomb per second we call 1 amp. So A is an amp, which is short for an ampere, which is named for a different Frenchman. We have electrical current. A lot of different sources, textbooks, whatever, will try to compare electrical current to water currents, and that's a little bit tricky. They'll also talk about electrical current as related to like traffic flow, and that's also a little bit tricky. One way that I think makes a lot of sense is this. Let's say I have a battery like this. A battery is just an object that has a potential difference across its sides. So what that means is we have maybe a high potential up here on the left side, which we generally just write as a positive up here on the top side, and a low potential on the bottom side. Now if I have a charge in here, this charge wants to move from high to low potential, so it's going to go this way. I don't want it to do that, so instead I put a barrier in the middle of this, and because of that barrier, I will say that my charge can only move in one direction through here. This says my charge can move in this direction, but not in this direction. That's a problem because it doesn't want to move in this direction. That would be moving from low to high potential. But let's see what happens. If I have a piece of wire like this, then there might be a charge sitting right here. This sees a high potential here, and it wants to move down this way. Why doesn't it? This wire is made of metal. Metal is made of atoms, as most stuff is, right? So when it wants to move, when this charge wants to move to this next spot, there's already something in this spot. It doesn't have a spot to move to. So what we need is for that one, for the second charge, to move into a new spot. That would vacate this first square, and now this charge could move into it. The problem is, there's already something sitting there, and we can keep going down the line. But being that the wire is made of something, and something is made of atoms, there will already be a charge in each new location. If this last spot doesn't get vacated, then this charge can't jump into it. If this charge can't jump in, this spot won't be vacated, which means this charge won't be able to jump here. Tracing that all the way back down the line, that means this first charge can't go anywhere until that last charge has somewhere to go. So, I keep this path going, and I connect back to the other side of my battery. Now, if I look at these locations all the way down, this wants to jump, this wants to jump, this wants to jump, and I've got particles in all of these locations already. Each wants to jump to the next location, and that works out fine now because this last particle, it has somewhere to go. It's going to take the spot that's vacated by the first one. So when we think about these charges, when we think about an electrical current, maybe the easy way to think about this is to think about these like ball chains that look like this. You see them on like military dog tags, right? You have something like this, and instead of thinking about this one particle, this one charge moving all the way down the line, think instead we've got this, and we're just going to rotate it a little bit. So when we rotate it, we rotate this one to the next spot, which is going to rotate the whole chain by one location. Now I've got a current moving all the way through because in any one spot that I look at, I've got particles passing through, I've got charges passing through. This one individual charge doesn't have to jump all the way to this location for something to happen here, because by this first charge moving one spot over, there is another charge that moves past that location. That's kind of a basic idea of current and where that goes. We'll talk about what causes it and what to do with it in future videos. For right now, that's an intro.